Welcome to NVIDIA.
Welcome to GTC. I hope all of you are well. We have really big announcements and cool things to show you today. But first, let me share the new I Am AI. It's a work of love by NVIDIA's creative team and beautifully tells the stories of the impactful work you do.
I am a visionary, expanding our understanding of the smallest particles. The infinite possibilities of the universe. I am a guardian, protecting us on all of our journeys. Ensuring our most precious passengers make it home safely. I am a healer, searching for hidden threats in every cell. Delivering precise care with every breath. I am a helper, taking on complex tasks in the most challenging environments, and giving our crops room to grow. I am a creator, transforming the very fabric of our everyday lives, and using the creative DNA of the masters to inspire a new generation of art. I am a learner, taking just minutes to discover how to crawl, walk, and stand on my own. I am a storyteller, giving emotion to words. I am the composer of the music. Brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Doctors can now sequence the human DNA in a couple of hours. and predict the 3D structure of the DNA from the amino acid sequence. Researchers can use computers to generate new drug candidates. And inside a computer, test a new drug against the target disease. AI is learning biology and chemistry, just as AI has learned images, sounds, and language. Once in the realm of computers, fields like drug discovery will undergo the same revolution we're witnessing in other areas impacted by AI. None of these capabilities were remotely possible a decade ago. Accelerated computing at data center scale and combined with machine learning has sped up computing by a million X. Accelerated computing has enabled revolutionary AI models like the Transformer and made self-supervised learning possible. AI has fundamentally changed what software can make and how you make software. Companies are processing, refining their data, making AI software, becoming intelligence manufacturers. Their data centers are becoming AI factories. The first wave of AI learned perception and inference, like recognizing images, understanding speech, recommending a video, or an item to buy. The next wave of AI is robotics. AI planning actions. Digital robots, avatars, and physical robots will perceive, plan, and act. And just as AI frameworks like TensorFlow and PyTorch have become integral to AI software, Omniverse will be essential to making robotic software. Omniverse will enable the next wave of AI. We will talk about the next million X and other dynamics shaping our industry this GTC. Over the past decade, NVIDIA accelerated computing delivered a million X speed up in AI and started the modern AI revolution. Now AI will revolutionize all industries. The CUDA libraries, the NVIDIA SDKs, are at the heart of accelerated computing. With each new SDK, new science, new applications, and new industries can tap into the power of NVIDIA computing. These SDKs tackle the immense complexity at the intersection of computing, algorithms, and science. The compound effect of NVIDIA's full-stack approach resulted in a million X speedup. Today, NVIDIA accelerates millions of developers and tens of thousands of companies and startups. GTC is for all of you. It is always inspiring to see leading computer scientists, AI researchers, roboticists, and autonomous vehicle designers present their work at GTC. We can see AI and accelerated computing's expanding reach and impact from the new attendees and talks. This year, we see Best Buy, Home Depot, Walmart, Kroger, and Lowe's working with AI. LinkedIn, Snap, Salesforce, DoorDash, Pinterest, ServiceNow, American Express, and Visa will talk about using AI at scale. And you can look forward to seeing talks from healthcare companies, GSK, AstraZeneca, Merck, Bristol-Myers Squibb, Mayo Clinic, McKesson, and Eli Lilly. GTC 2022 is going to be terrific. The GPU revolutionized AI. Now, AI on GPUs is revolutionizing industries and science. One of the most impactful to humanity is climate science. Scientists predict that a supercomputer, a billion times larger than today's, is needed to effectively simulate regional climate change. Yet it is vital to predict now the impact of our industrial decisions and the effectiveness of mitigation and adaptation strategies. NVIDIA is going to tackle this grand challenge with our Earth 2, the world's first AI digital twin supercomputer, and invent new AI and computing technologies to give us a billion X boost before it's too late. There is early evidence we can succeed. Researchers at NVIDIA, Caltech, Berkeley Lab, Purdue, Michigan, and Rice Universities have developed a weather forecasting AI model called ForecastNet. ForecastNet is a physics-informed deep learning model that can predict weather events such as hurricanes, atmospheric rivers, and extreme rain. ForecastNet Learn to predict weather from 40 years of simulation-enhanced ground truth data from ECMWF, the European Center of Medium Weather Forecasting. For the first time, a deep learning model has achieved better accuracy and skill on precipitation forecasting than state-of-the-art numerical models. It makes predictions 4 to 5 orders of magnitude faster. What takes a classical numerical simulation a year now takes minutes.
Atmospheric rivers are enormous rivers of water vapor in the sky, each carrying more water than the Amazon. They provide a key source of precipitation for the western U.S., but these large, powerful storms can also cause catastrophic flooding and massive snowfalls. NVIDIA has created a physics ML model that emulates the dynamics of global weather patterns and predicts extreme weather events, like atmospheric rivers, with unprecedented speed and accuracy. Powered by the Fourier neural operator, this GPU-accelerated AI-enabled digital twin called ForecastNet is trained on 10 terabytes of Earth system data. Using this data, together with NVIDIA Modulus and Omniverse, we are able to forecast the precise path of catastrophic atmospheric rivers a full week in advance. ForecastNet takes only a fraction of a second on a single NVIDIA GPU. With such enormous speed, we can generate thousands of simulations to explore all possible outcomes, allowing us to quantify the risk of catastrophic flooding with greater confidence than was ever possible before.
NVIDIA is pioneering accelerated computing, an approach that demands full-stack expertise. We built NVIDIA like a computing stack, a neural network, in 4 layers: hardware, system software, platform software, and applications. Each layer is open to computer makers, service providers, and developers to integrate into their offering however best for them. I will announce new products at each of these layers today. Let's get started. The progress of AI is stunning. Transformers open self-supervised learning and unblock the need for human-labeled data. We can use enormous training sets with transformers and learn more robust and more complete representations. Because of transformers, model and data size grew, and model skills and accuracy took off. Google BERT for language understanding, NVIDIA Mega Mobile for drug discovery, and DeepMind AlphaFold are all breakthroughs traced to transformers. Transformers made self-supervised learning possible, and AI jumped to warp speed. Natural language understanding models can learn without supervision from vast amounts of text, which is then refined with a small amount of human-labeled data to develop good skills for translation, questions and answers, summarization, writing, and so much more. AI is building chips like ForecastNet and OrbNet. Physics ML models are learning physics and quantum physics. The conditions are prime for significant breakthroughs in science. Generative models are transforming creative design, helping build virtual worlds, and soon revolutionizing communications. Like NERF, neural graphics networks that learn 3D representations from 2D images will elevate photography and help us create digital twins of our world. AI is racing in every direction. New architectures, new learning strategies, larger and more robust models, new science, new applications, new industries, all at the same time. Here's an amazing example. This AI-powered character is animated using a physics-based reinforcement learning model. Let's take a look.
We are using reinforcement learning to develop more lifelike and responsive physically simulated characters. Our character learns to perform lifelike motions by imitating human motion data, such as walking, running, and sword swings. Our character is put through an intense training regimen for 10 years in simulation. Thanks to NVIDIA's massively parallel GPU simulator, this just takes 3 days of real-world time. The character then learns to perform a large variety of motor skills. Once the character has been trained, he can use those skills that it has learned to perform more complex tasks. Here, the character is trained to run to a target object and knock it over. We can also steer the character to walk in different directions, like you would with a game character. Our model allows the character to automatically synthesize lifelike responsive behaviors to new situations. We can also control the character using natural language commands. For example, you can tell the character to do a shield bash or swing its sword. We hope this technology will eventually make animating simulated characters as easy and seamless as talking to a real actor.
NVIDIA AI is the engine behind these innovations, and we are all hands on deck to advance the platform, solving new problems, getting it everywhere, and making AI more accessible. NVIDIA AI is a suite of libraries that span the entire AI workflow, from data processing and ETL feature engineering to graph, classical ML, and deep learning model training to large-scale inference. NVIDIA DALL-E, Rapids, cuDNN, Triton, and Magnum IO are among the most popular libraries. We use the libraries to create specialized AI frameworks that include state-of-the-art, pre-trained models and data pipelines that make it easy to scale out. Let me touch on a few of our updates at GTC. Hundreds of billions of web interactions a day, like search, shopping, and social, generate trillions of machine learning model inferences. NVIDIA Triton is an open-source, hyperscale model inference server, the grand central station of AI deployment. Triton deploys models on every generation of NVIDIA GPUs, x86 and ARM CPUs, and has interfaces to support accelerators such as AWS Inferentia. Triton supports any model: CNNs, RNNs, transformers, GNN, decision trees, any framework: TensorFlow, PyTorch, Python, Onyx, XGBoost. Triton supports any query type: real-time, offline, batched, or streaming audio and video. Triton supports all ML platforms: AWS, Azure, Google, Alibaba, VMware, Domino Data Lab, OctoML, and more. And Triton runs in any location: cloud, on-prem, edge, or embedded. Amazon Shopping is doing real-time spell checking with Triton, and Microsoft is using Triton for its translator service. Triton has been downloaded over 1 million times by 25,000 customers. NVIDIA Riva is a state-of-the-art speech AI that is end-to-end based on deep learning. Riva is tunable. Riva is pre-trained with world-class recognition rates. And then customers can refine with custom data to learn industry, country, or company-specific jargon. Riva Speech AI is ideal for conversational AI services. Snap, RingCentral, Core AI, and many others are using Riva. Today, we're announcing the general availability of Riva. Release 2.0 has speech recognition in 7 languages, neural text-to-speech with male and female voices, and custom tuning with our Tau transfer learning tool. Riva runs on any cloud and anywhere with NVIDIA GPUs, basically everywhere. Maxine is an SDK featuring state-of-the-art AI algorithms for reinventing communications. Video conferencing encodes, transmits, then decodes images and sound. Computer vision will replace image encoding, and computer graphics will replace image decoding. Speech recognition will replace audio encoding, and speech synthesis will replace audio decoding.
There's something new in the world of
55 years after AT&T demonstrated the picture phone at the World's Fair in New York, AI will reinvent video conferencing. Remote work is here to stay. We need virtual live interactions more than ever. Maxine is an AI model toolkit used by developers to reinvent communications and collaborations. Maxine has 30 models today. The GTC release adds new models for acoustic echo cancellation and audio super resolution. Let's take a look at what Maxine can do.
Millad Maxine reinvents real-time video communication with the magic of AI. Thanks to Maxine, we can now hear and see each other better, and we feel more connected and included, even when language becomes a barrier. To stay engaged with my audience, Maxine helps me keep eye contact with everyone on the call, whether it's one person or 100, and even if I'm reading a script.
¿Cómo puedes superar las barreras del lenguaje con Maxine?
While I don't speak Spanish, with Maxine's help, now I can.
Ahora puedo hablar tu idioma con mi propia voz. Impresionante, ¿no? Magnífico.
Pas mal, mais est-ce que Maxine comprend aussi d'autres langues?
Oh yes, absolutely.
Maxine me permet aussi de parler français. Et bien d'autres langues. Wir würden mir die von Maxine erzählen, aber du musst dich bis zur nächsten Geschichte gedulden. Bleib dran, damit du nichts verpasst. Wunderbar, ich bin dabei.
Recommenders are personalization engines. The internet has trillions of items and is constantly changing. News, social videos, new products. How do we even know what is out there? Recommenders learn the features of items, your explicit and implicit preferences, and recommend things likely of interest to you. A personalized internet. Advanced recommendation engines drive the world's consumer internet services. In the future, it will also drive financial services, healthcare services, vacation planners, and much more. NVIDIA Merlin is an AI framework for recommender systems. Merlin consists of end-to-end components of a recommender pipeline, including feature transforms, retrieval, to ranking models. With NVIDIA Merlin, companies can quickly build, deploy, and scale state-of-the-art deep learning recommender systems. Snap uses Merlin to improve ad and content recommendations while reducing costs by 50% and decreasing serving latency by 2x. Tencent WeChat uses Merlin to achieve 4 times lower latency and 10 times throughput for short video recommendations. Tencent's cost is halved, moving from CPU to GPU. At GTC, we are announcing the 1.0 release and general availability of the Merlin. Transformers revolutionize natural language processing. Training large language models is not for the faint of heart. It is a grand computer science challenge. OpenAI's GPT-3 is 175 billion parameters. NVIDIA Megatron is 530 billion. And Google's new Switch transformer is 1.6 trillion parameters. NeMo Megatron is a specialized AI framework for training large language models up to trillions of parameters. To get the best performance possible on the target infrastructure, NeMo Megatron does automatic data, tensor, and pipeline parallelism, orchestration and scheduling, and auto-precision adaptation. NeMo Megatron now supports any NVIDIA systems and automatically does hyperparameter tuning for your target infrastructure. NeMo Megatron is also cloud native and supports Azure, with AWS coming soon. AI, the creation and production of intelligence, is a giant undertaking and touches every aspect of computing and every industry. NVIDIA AI libraries and SDKs accelerate software, platforms, and services throughout the AI ecosystem. Even with excellent tools and libraries, developers of NVIDIA must dedicate significant engineering to ensure performance, scalability, reliability, and security. So we have created the NVIDIA AI Accelerator Program to work with developers in the AI ecosystem to engineer solutions together that customers can deploy with confidence. NVIDIA AI democratizes AI so that every industry and company can apply AI to reinvent themselves. One of the most impactful is the revolution in digital biology. AI accelerates DNA sequencing, protein structure prediction, novel drug synthesis, and virtual drug testing. Funding for AI drug discovery startups surpassed $40 billion in the past couple of years. In silico medicine has just sent its first AI-discovered drug to enter human clinical trials. The novel drug target was discovered in less than 18 months, years faster than previously possible. The conditions are prime for the digital biology revolution. I can't imagine a greater purpose for NVIDIA AI. AI applications like speech, conversation, customer service, and recommenders are driving fundamental changes in data center design. AI data centers processes mountains of continuous data to train and refine AI models. Raw data comes in, is refined, and intelligence goes out. Companies are manufacturing intelligence and operating giant AI factories. The factory operation is 24/7 and intense. Minor improvements in quality drive a significant increase in customer engagement and company profits. New organizations called ML Ops are showing up in companies around the world. Their fundamental mission is to efficiently and reliably transform data into predictive models, into intelligence. The data that they process is growing exponentially. The more predictive the model, the more customers engage the services, the more data is collected. The computing infrastructure of ML Ops is fundamental, and its engine is the Ampere Architecture A100. Today, we are announcing the next generation. The engine of the world's AI computing infrastructure makes a giant leap. Introducing NVIDIA H100. The H100 is a massive 80 billion transistor chip using TSMC 4N process. We designed the H100 for scale-up and scale-out infrastructures, so bandwidth, memory, networking, and NVLink chip-to-chip data rates are vital. H100 is the first PCI Express Gen 5 GPU and the first HBM3 GPU. A single H100 sustains 40 terabits per second of I/O bandwidth. To put it in perspective, 20 H100s can sustain the equivalent of the entire world's internet traffic. The Hopper architecture is a giant leap over Ampere. Let me highlight 5 groundbreaking inventions. First, the H100 has incredible performance. A new tensor processing format, FP8. H100 has 4 petaflops of FP8, 2 petaflops of FP16, 1 petaflops of TF32, 60 teraflops of FP64 and FP32. Designed for air and liquid cooling, H100 is also the first GPU to scale in performance to 700 watts over the past 6 years through Pascal, Volta, Ampere, and now Hopper. We developed technologies to train with FP32, then FP16, and now FP8. For AI processing, Hopper H100's 4 petaflops of FP8 is an amazing 6 times the performance of Ampere A100's FP16, our largest generational leap ever. The transformer is unquestionably the most important deep learning model invented. Hopper introduces a transformer engine. The Hopper transformer engine combines a new tensor core and software that uses FP8 and FP16